Hi, programmer friend. I hope things are great with you. We're going to take a quick look here at linked list. Whenever we code something, the first thing we really want to do is understand the domain model, understand the model, understand what we're going to code, right? We want to know what the subject. If we understand that, we have a really good chance. So let's take a look at the logic there for linked list logic. And I won't go through this step by step. These are actually not very long sections. They're actually short. So pop through all those sections there. Let's just take a quick look at a couple. Let's look at concepts here. So we always want to look at just the context of our subject, right? And first we're looking at linked lists. So really just this area right here, right? That's where we really want to look. And we see that if you look through this, you'll see that we really want to come up with, we just have a first node and we have a last node. And we also have a bookkeeping item here. We keep size. So this would be 3 instance variables, right? Just 3 instance variables on our linked list object. So that's pretty good. Pretty simple, right? And this tells us more about it here, and you can read through that. So there's our design here. Let's take a look here. So the node, we can see from that previous concept thing that we have nodes. Nodes are really going to be where a lot of the well, it's where the data is, of course, and it is where a lot of our logic can be too. So that's the real meat and potatoes of this object. So again, linked list is pretty lightweight. Then we have these node objects that hang on the data. So pretend these are city objects here. I mean, they're holding on to city objects, I should say. We have a list of 4 cities: Brooklyn Park, Robbinsdale, Golden Valley, New Hope. Let's say 4 cities. Each node hangs onto one city, and that city is the data or the element. So remember, in context, we talked about that context there, the linked list. Now the node context, we'll get to that here, and we want to keep it as simple as we can, so we don't want to think about too much at once. We just talked about the node has data, so that's 1 instance variable there we're thinking about. The node also should keep track of a previous node and a next node. So in all, we want to keep track of the 3 things really, right? We have the data, we have the next and the previous node, and that's our node. So that's our node object. Notice how this is simple, right? That is simple, and when we talked about linked list, that was also simple right there. But if we look at the whole big picture, it gets more complex. So we try not to do that. We try to look at just the small pieces one at a time, right? So accomplishing this linked list is really going to take 2 partners. One is going to be the linked list itself, the primary object. Then we have these nodes. So 2 classes, right? A linked list class and a node class. Also, iterator is really helpful, optional. You can implement an iterator, and I'll talk about that in a second too. All right, well, let's look at a little bit of code for what we might come up with here. So we know we're going to have 3 ivars. We talked about previous node, next node, and data. And excuse me, that's the node. Let's go to the list here. 3 ivars: first node, last node, and we're going to keep track of size. So 3 instance variables. You might add more. Generally, the less is better, because every node you add, you have to keep track of it, and it adds complexity. It adds chances for errors. So minimal number of ivars, just enough, usually produces simpler code. A couple of the simple, let's just knock off a couple simple methods from a logic perspective. Size, we just had to return that size value, right? Of course, we're assuming we keep track of it, which we will in our code. Again, is empty. Can just do this, just like dynamic array did, right? Okay, let's go to some other ones. The for each method here. That's what we're doing is iterating through this list. This is a linked list, remember? We're iterating through this linked list object, all the elements in it, and we are doing this action on each one. So we're just doing the action function, and this is pseudocode or logic, right? This can be converted to Java or Python or whatever we want to convert it to in terms of programming language. So we're using an iterator here, and look at how nice and simple that is. You wouldn't have to use an iterator. You could also iterate through the elements in different ways. You could grab that first node, right, and keep iterating down through that. But the iterator itself is real nice, and I'll show you that in a second. I actually have that coded there for you. So, to array, that actually just, we're going to create a empty array, and again an iterator. This is actually when we say array here, we mean the native object for the language. So in Java, that would be something like an array list or something, right? A different, whatever the programming language has. We're creating one here with that size, and then we're iterating through and setting the values and returning it. So we're converting this linked list into get rid of that linked list into a standard array. The get method is real simple. We do an exception handler check here, just checking the index, but the actual logic here, we're just going to get the node and get the data from that node. So the get node method is a helper method. I love helper methods. Makes our code simpler, I think. If we go to the get node method, we will see here we're getting the first node, and that's get node at an index, that is, and we're setting the count to 0, and we simply while that node is not equal to null, because remember in our logic here, if we go back to our logic, the end node is the next pointer is null. This is the previous pointer, and this is the next pointer. The yellow is the next pointer for each node. Previous pointer is green. So when we get to the end, we're just iterating through the nodes, and we get to the end, that next pointer is going to be null. That's how we know we're at the end. So we can iterate that way. So we are not equal to null. We are while we're not equal to null, if we match the index, we have our match. And this is not going to make perfect sense probably to you in the first pass, but what you want to do is do some testing, right? And here's just an example of some real simple tests. So this video is getting a little long. I don't want to make it too long for you. You can look through it as much as you want for ideas. Again, this is just and here's an example of an iterator here for you. And actually, you know, do as much as you can. Try to do it without watching this video, especially this next part, what I'm going to tell you. The doubly linked node is actually it's actually really given to here. The logic for it is given. So I don't want to ruin your fun. So try to do it without it first. All right. And the methods for the logic here in the linked list class, there's just some of the methods, not all of them, but some of them. Kind of get the core working. And so that's about it. That is a quick overview of linked list. And again, you know, the main thing again is to understand the domain, the model that we're coding, which is a linked list. So you want to look through, you know, these sections, and they're very, very short, each one. So it won't take you very long. And even the learning is iterative. We use the word iteration a lot as coders, don't we? Even the iteration is iterative. The learning is iterative. We learn a little bit, we learn a little more, we get stuck. We code a little bit, loop, loop, loop. We'll talk to you soon.